Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about the Leetcode problem number 832, flipping an image. First of all, let me read the problem. Given an n into n binary matrix image, flip the image horizontally, then invert it and return the resulting image. And basically they are saying that just flip the rows and invert it, that is 0 to 1 and 1 to 0. Let us see. For example, flipping 1 comma 1 comma 0 horizontally results in 0 comma 1 comma 1. So we are just having this array, just flipping. Fine. Now to invert an image means 0 is replaced as 1 and each 1 is replaced as 0. For example, inverting 0 1 1 is equal to 1 0 0. Fine. Now let me take this example and explain you. 1 1 0 1 0 1, then 0 0 0, then 0 0 0. This is what the matrix is, right? Now first I want to flip. After flipping, my result will be 0 1 1 and 1 0 1 and 0 0 0. Once I flip, the result will be like this. Now I want to invert it. So 0 to 1 0 0 0 1 0 1 1 1. Fine. So this is my final result. This is my output. So how to approach this problem? Just see here. Again, I write the problem. 1 1 0 1 1 0 1 0 1 0 0 0. Now I create another matrix. Of the same length. 3 into 3 matrix. 3 rows, 3 columns. Now reverse this row and store here. Like first my I value is from 2, then my I value is 1, then my I value is 0. Store that 0 1 1, then my I value is at 2, then 1, then 0. So 1 0 1. Now again like that, my I value is at 2, so 0, then my I value is at 1, then it's at 0. Fine. Now invert in the same array, right, in the same matrix. But how to invert it? Just put a condition. If that matrix I and j is equal to 1, then change it as 0, else change that matrix row column as 1, right? So it can change. How it can change? 1 0 0 0 1 0 1 1 1, right? But still, instead of writing these 4 boring lines, I can write matrix of I and j is equal to matrix of I and j XOR 1. What is the property of XOR? Just see here. A XOR B means when these both inputs are same, it results in 0. When these both inputs are different, it results in 1. Fine. Now when I do XOR with 1, it is 0, and when I do XOR with 0, it is 1. So basically the XOR is for toggle, right? The XOR is used for toggle. So this is what the first approach. Fine. This is what the first approach. How I can optimize it? Still, how I can optimize it? Because for that above approach, the time complexity is O of n into m. That is matrix row and matrix column. and space complexity is also n into m. But whether I can do it with space complexity of O of 1, whether I can do it, answer is yes. Answer is yes, because what we are doing is just we are reversing. Just we are reversing. We know whether for reversing we want an individual auxiliary space. No, no, right? We can also swap. We can also swap. How we can swap? This number can be swapped with this number. This one can be swapped with this one. This 0 can be swapped with this 0, right? So my approach is like take for example 110. Take for example 110 101 000. First of all, take this 1 and take this 0. Swap it, swap it, swap it. If I swap it, I get 0 and 1. Now do XOR with both. Here I get 1, here I get 0. Now put that here. Put that here. Right? Right? Now for this, I also XOR for 1. Now it goes to 0. Fine, fine. Because swapping this 1 again, it receives 1 is equal to 1 because it is first index. Swapping first index with first index, it results in 1, and with doing XOR 1, it results in 0, 0, 0. Right? Now I got the first row. Now same applicable to second row. Swapping this 2 results in 1, 1, and doing XOR with these two ones will get here also 1 XOR 1, here also 1 XOR 1. So 0, 0, 0, 0. Then in next iteration, I swap the 0 with the 0 and XOR with 1, which results in 1. Fine. Now I swap the 0 with the 0 and then do for XOR. Do for XOR operation. Now I get 1, 1, and again I will do individually for this 0 because the 0 is again swapped with this 0, right? Now this is also 1. So this is my final result. My final result. See here. This final result is same as the optimal approach. So what is the time complexity? What is the time complexity? The time complexity is O of n into m for traversing to number of rows and number of columns in matrix, and space complexity is O of 1 because I am just swapping in the existing matrix. So this is what the problem, right? Let me explain the approach. Let's see here. This is for the brute force, right? I just wrote a result. In that I declared a list. Now for in range of len of image, inter is another list that stores the individual rows. Now for j in range of len of image of 0, minus 1, minus 1, minus 1, so that I am traversing from the individual rows last. That is, see here, take for example, I am traversing from here. First here, then here, then here, then here, then here, then here. Fine. I am traversing from this way. That's what this for loop tells. Then if image of I of j is equal to 0, then inside my inter list I will append 1. Else inside my inter list I append 0. Then finishing this whole for loop, right? Finishing this whole for loop will result in one individual row, and I going to append that individual row to the result. Fine. Now I will return the result. This is what the first approach. Let me run it. Fine. Now, what is the optimal approach? What is the optimal approach? The optimal approach is by using the swapping. By using swapping. See here, n comma m is equal to len of image comma len of image of 0. Then for rows in image, I am taking individual rows from the image. Okay, in the image matrix, I am taking the individual rows and storing the rows. That is the meaning of this syntax. Then L comma R is equal to 0 comma m minus 1, while m is less than or equal to r. Then I will swap these both if I didn't give the XOR1, it just swap, but I don't need to swap alone. I need to swap, and also I need to XOR with one. I need to XOR with one. That's why to reduce another for loop, I just use a XOR symbol here. XOR symbol here. Fine. Now R minus is equal to 1 and L plus is equal to 1. Then I return image. Right. So this is the optimal approach. Let me run it. Yes, this is submitted. Thank you.